Until now, I thought that the golden ratio was only important when dealing with a Fibonacci sequence. I was wrong. Today I discovered that the golden ratio appears in all sequences which consists of the sum of the two previous numbers. As the number of previous added terms increases, the value of the ratio between two consecutive numbers approaches the value 2. When all previous terms are added, as the sequence increases, the ratio is equal to 2. The sum of the two previous terms of the Fibonacci sequence yields the next term in the sequence. One starts with 1 followed by 1, and from there, we add the two previous numbers. On the left, you can see the first 15 terms of the sequence. As the number of terms of the sequence increases, the ratio between two consecutive numbers approaches the golden ratio. For example, 987 divided by 610 gives us a good approximation of the golden ratio. Now let's take a look at the new sequence, which I call g of k. In this sequence, one has 3 terms instead of 2. The first 3 terms of g of k are 0, 1, and 1. Adding 3 consecutive terms gives us the next term. When one divides two consecutive terms, the result is different from the golden ratio. Dividing 3136 by 1705 doesn't yield the value of the golden ratio. Instead, a different number appears. Now the function h of n begins with values different from those of the Fibonacci sequence. However, the ratio between two consecutive terms approaches the golden ratio. In the sequence h of n, only two previous terms are added each time. The function g of n is different. One keeps adding previous terms to generate the next term. In this case, the ratio between two consecutive terms is always 2. So what is the relation between the golden ratio and other sequences? The answer is that the golden ratio will appear in the sequence every time one keeps adding just two previous terms. If one adds more terms, the value will approach 2.